Today we are going to see some important points about CET and NEET and JEE. Some important points for these exams. Suppose here we consider in thermodynamics. Here we can see that is the first point. That is it is the branch of physics which deals with the conversion of heat into other form of energy, and here we can see the H converted into different forms of energy. This is about the thermodynamics. Now second, we consider here the system. We consider different coordinates, that is pressure, volume, temperature, internal energy. These are the different coordinates. Now we consider the next point, the variables PVT, pressure, volume, temperature, energy, whose knowledge specifies the state of thermodynamic system, and we call it as a thermodynamic variables. We call them as a thermodynamic variables. Now all these variables are related by some equation. We call it the equation of state. You know, that is PV is equal to RT or PV is equal to nRT. Now if we plot the graph, that means about two variables. One is constant, then they are called as PV diagram, PT diagram, VT diagram. All these they are diagram, and all the curves shows a thermodynamic process. And we consider area under the curve. Suppose we consider PV diagram, then area under the curve shows work done. This is the important point. Area under the curve, it shows the important, that is work done. Now work done on or by the gas depends on its initial and final states. Also final state and the path adapted between the two states. Now here we consider different types of thermodynamic process. First, isobaric process. What is mean the isobaric process? It is a thermodynamic process. Here pressure is constant. Next one, we consider here the equation of state for this process. Suppose same, we consider V upon T is equal to constant. Now in isobaric compression, temperature decreases. If there is a compression, then temperature decreases and internal energy flows out in the form of heat energy. While in isobaric expansion, temperature increases and heat flows into the system. The amount of heat delta Q transferred is given by this equation, that is delta is equal to N Cp delta T, where N is number of moles. Also isobaric expansion is given by Vt is equal to V0 1 plus gamma 0 T, where gamma 0 is equal to 1 upon 273 per degree centigrade. We call it as a coefficient of volume expansion. Now we consider next one, second process, isochoric process. What is meant by isobaric process? This is isobaric. Now, it is a thermodynamic process in which volume is constant. Here you see, here pressure is constant, here we will write volume is constant. And equation of state is given like this. P upon T is equal to constant. Now, here delta Q can be given like this. Delta is equal to N CV delta T, where N is number of moles. And here we consider pressure Pt is equal to P0 1 plus gamma P into T, where gamma P is equal to 1 upon 273 per degree centigrade. This is about the isobaric process. Now we consider the third one, that is isothermal process. See here, it is a thermodynamic process in which temperature is constant, and here equation can be given like that. PV is equal to constant. Now here the isothermal curve or PV diagram is like a hyperbola. Shape is like a hyperbola, and we consider the slope of the isothermal curve at any point is given, that is we write dP upon dV is equal to minus P upon V. It is negative and is equal in magnitude to the ratio of P and V at that point. This is about isothermal. We consider fourth one, adiabatic process. Adiabatic process. It is the process in which heat exchange by the system to or from the surrounding to is 0, or we can write here delta Q is equal to 0. No change in heat. And equation of state can be given like this. PV raised to gamma is equal to constant. And gamma means, here you see, gamma means Cp upon Cv. You know all this. Now here dP by dV, the slope is equal to minus gamma into P upon V. This is about the that is a adiabatic process. Now here we consider next one, that is work done. Suppose I will consider next point. Work done in thermodynamic process. Work done in thermodynamic process. Work done in thermodynamic process. Here you see simple equation, that is W is equal to, we write, that is P into Vf minus Vi, or W is equal to integration Vi to Vf P dV. Now for isobaric process, W is equal to, we can write P into Vf minus Vi. Pressure is constant. Secondly, for isochoric process, W is equal to 0 since delta V is equal to 0. Third one, for isothermal, W is equal to, we write nRT log to the base E into Vf minus Vi, which is equal to, we write nRT log to the base E Pi upon Pf, or which is equal to, we write here Pi Vi log to the base E Vf upon Vi. Now for fourth we consider adiabatic. For adiabatic process we write here W is equal to Pi Vi minus Pf Vf upon gamma minus 1, or we write here Nr into Ti minus Tf upon gamma minus 1, which is equal to N Cv into Ti minus Tf. This is about the adiabatic process. Now we consider next, that is amount of heat added or removed by n moles of gas. We write here amount of heat added or removed by n moles of gas. Q is equal to, we write here N Cv delta T. For we consider that is choric process or isometric process, and Q is equal to N Cp delta T. This is for that is a isobaric process. And SI unit of heat is a calorie, and you know 1 calorie is equal to, that is 4.186 joules. Or we can take 4.2, nearly equal to 4.2 joules. Now you know about internal energy, that is according to kinetic theory of gases, mean kinetic energy, mean K can be given, that is 3/2 kT. This is about the kinetic energy. Also internal energy delta U can be given like this, 3/2 mu R. We can say instead of mu we write Nr delta T, increase in internal energy. Now you know about the first law of thermodynamics. What is first law? Delta Q is equal to delta U plus delta W, or delta U is equal to delta Q minus delta W. Instead of delta W we can use only W. Now you know that is about specific heat at constant volume, Cv. It is the amount of heat absorbed by 1 mole or 1 gram of substance to increase its temperature by 1 degree centigrade or 1 degree Kelvin. Also Cp means also at constant volume, and it is at constant pressure. And relation between these two, that is Cp minus Cv, is equal to R. Also Cp upon Cv, we call it the adiabatic constant gamma. Adiabatic constant gamma. This is all about that is different formulas, and we have already discussed about second law, heat engine, refrigerator, Carnot heat engine, efficiency. You remember all these points? Okay, thank you.